This section we're going to do today is called 6.3. We're going to prove triangles are similar by AA. So we are going to encounter a couple of postulates and theorems coming up here. And last semester we had a whole unit, or we ended last semester with proving two triangles were congruent. And we had the 5 ways we outlined in the foldable. We're going to encounter here ways to show items are similar. So the first one is called the angle, or just AA, similarity postulate. And it says if two angles of one triangle are congruent to two angles of another, then the triangles are similar. So remember we had a false shortcut of AAA, and that's because the triangles could be different sizes. Well, it falls under similarity because they are similar. So if you look at the diagram here, it's called AA, but technically all 3 angles in one triangle are congruent to 3 in another. But because, remember that third angles theorem that would explain why L and Z are congruent? Because we can just do the math with triangle sum. So we don't really have to worry about the third angle because it's always going to be congruent. Now, I want to show you, I want to switch over here and show you, kind of a graphic. So if I take this triangle and I just drag it around, take a look at the angles. See how the angles are never changing from being congruent between the two triangles. So that is what keeps them similar. The side lengths are changing proportionally, but the angles are never changing. And this is why it could not be a congruence theorem. It's a similarity theorem. All right, so this is a good way to show you how that is going to work for similarity. Okay, so let's use that idea. Example 1, determine whether the triangles are similar. All we know right now is the AA postulate. If they are, write a similarity statement. So here's what I see. Angle B and angle E are congruent. We've got one. Angle B is congruent to angle E. Now, I see 38 and 52, but I'm going to calculate the measure of angle A because maybe it's 52. So if I can do the triangle sum theorem if I want to. Take the 90 away from 180, take out the 38, and I get 52. So I don't really need to check angle F, even though I know it's going to be 38, but I can now also say angle A is congruent to angle D. So are the triangles similar? Yeah, they are similar by AA. I'll go ahead and write the whole thing out. AA similarity postulate. Okay. Okay, let's do a similarity statement. Okay, so this is where we name the two triangles with the similarity symbol. So I'm just going to start, doesn't matter how you begin as long as the second one corresponds. ABC is similar to, so A is 52, so it has to go with D, and then I went to the 90, and then the 38. So happened to be in alphabetical order. Doesn't always work out that way, but this one did. All right, so that's my similarity statement. Okay, try A and B below. Pause the video. I want you to determine if they're similar. If they are, go ahead and write that statement. Okay, on this first one, I know these are isosceles, so I can calculate that number. So if I do 180, take out 115, I get 65. And then if I divide that by 2, I know that I get 32.5. And so therefore, these are similar by AA. I'm just going to say here, yes, by AA. And then my statement, now yours could be slightly different than mine, but still be correct. I'm going to start with T and go to U and then V is similar to H, J, K. All right, so that's the first one. Okay, number 2. I have a reflexive angle, all right? I've got angle N, that's a part of PQN, and the same angle N is a part of LMN. So I'm just going to say angle N is reflexive. Okay. I also have corresponding, and I have a couple sets, but I'll just mark these two. L and P, so are M and Q. Okay, so I've got angle, I'll name the top one M, oops, let me make that better. MLN. Okay, so that's this one. Is congruent to the second one. I'm going to call it QPN, and then I'm just going to write corresponding. Okay, we're not really doing a formal proof, but just recognizing it. Okay, so they're similar. So my statement, triangle LMN is similar to triangle PQN. Okay. I guess I never really officially wrote over here, yes, by AA. We're going to learn a couple new theorems to go with AA in the next lesson. Okay, let's move on. Number 3. So let's go ahead and calculate some information here. So I am given here that the triangles are indeed similar. So what I'm thinking about is, okay, that tells me the corresponding angles are congruent and the corresponding sides proportional. All right, find two angle measures. So find the measure of angle M and the measure of angle P. Okay, I am going to, let's see, I'm going to go ahead and go like this for just a minute. I know that's 106 because of vertical angles. So to calculate angle P, I'm going to do 180 minus 106 minus 36. So this one is 38. So if I need angle M corresponds with angle Q because the triangles are similar. So that means that angle M is also 36 degrees. So the measure of angle M is 36 degrees. And then the measure of angle P, so P, right here, the first letter goes with L, the first letter. And so, actually, I just figured out, I don't need to know that it goes with L. I calculated a second ago that it was 38 degrees. Okay. All right, so we have 38, 36. All right, find the length of MN. So I'm going to write a proportion here. Okay, I'm going to write a ratio of sides. So MN, let me get rid of those red right there. So MN, let's see here. So MN corresponds to QN. Okay, these two right here in the name. So I need to set it equal to a ratio where I have numbers on it. So I have started with MN, which is in the top triangle. So let's start with the 33. So 33 goes with LM. And it's probably with PQ, but let's double check the name. LM and then PQ, yes. Okay, so let's plug our numbers in. So MN, I do not know. I'll call that X. QN is 20. LM is 33. QP is 30. Now, we can cross multiply. All right, so I'm going to have 30x equals, and so I need to do 20 times 33, which is 660. Oops. And then divide both sides by 30, and I get 11. So that is the length of MN. MN equals 11. All right. So I want to talk about this key concept below because it really ties into what we just did. So it just says that corresponding lengths in similar polygons. It says if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor. So you could argue that my scale factor was 33 over 30, okay, because it's the ratio of another set of sides. So that's really what we've been kind of talking about in that first lesson as well, that to get from one shape to another, we can use that scale factor to either scale something up or scale something down. Okay, we've got a couple more to look at here. All right, example 4. A building casts a shadow that is 78 feet long. So here's the shadow right there. At the same time, a nearby sign post that is 5 feet tall casts a shadow that's 39 inches long. Okay, shorter shadow. How tall is the building? Okay, so we can set a proportion up here. There's a number of ways to do this. So we can do in a ratio, we can do the height of the building in a ratio with the height of the sign. And then we can set that equal to, oops, gosh, my pen is not doing a good job right now. We can set it equal to the shadow to the shadow. Now, one thing to pay attention to here, let me get rid of those lines. Look at my units. Feet to feet, feet, but then inches. So I need to probably do a conversion here. So I'm going to change, I think I'm going to change my 39 inches into feet. So if there are 12 inches in 1 foot, so I need to go from inches to feet. So I need to divide my 39 by 12. Okay, so I'm going to do my 39 divided by 12. That's going to give me feet. So 39 divided by 12 is 3.25. So I've got, I'm going to change this into 3.25 feet. Now I'm going to do my proportion here. So I'm going to say x over 5 equals 78 over 3.25. Okay, so cross multiply. So I'm going to have 3.25. Gosh, sorry guys, my pen is all of a sudden giving me problems. I can't write anymore. Okay, I'm going to stop this video and try to fix my iPad, and I will come back and finish with the second video.